Welcome to our second order non-homogeneous differential equation. Now in the first video we looked at first order, now we'll be looking at second order. So quickly, just to explain what every term here means, second order essentially means we're dealing with an equation which contains the second derivative. So in this example here we have d squared x by dt squared. The non-homogeneous tells us that the equation is not equal to 0, and in this question it's equal to cosine of 3t. And obviously differential equation means we're dealing with derivatives. We have x's, we have t's, we have dx by dt and d squared x by dt squared. Now you can see here we first have to find the general solution of this equation and then find the particular solution. And as you can see here, 8 marks for part A and 5 marks for part B. Now they can have this split into multiple parts. So for example, the general solution, it could be split into 2 or 3 parts, where it says find the complementary function, then the particular integral, and then the general solution. Or it could be just one part, like here, where we just got to find the general solution straight away, and hence it's a hefty question with 8 marks. Now the thing that's good about these sort of questions is if you know the method, it's very straightforward. These sort of differential equations, with these second order ones, they punish you for not knowing the method, but they reward you heavily for knowing the method. Here you can get a whole 13 marks if you just simply follow this really simple method which I'm about to show you. If you label everything clearly and you just follow through with your workings out clearly, and you'll get all the marks very easily. So the first thing you should do, regardless if it's non-homogeneous or is homogeneous, is you should first find something called the auxiliary equation. Now essentially what this means is we're going to be replacing the derivatives. We're going to be replacing the dx by dt by m. We're going to be replacing the d squared x by dt squared by m squared, and we're going to be just having the 9x as just a 9. And essentially this is how we form the first part of our general solution. So basically we're going to replace it. So here we have m squared plus, and then don't forget the 6 here, so it's 6m, and then it's just plus 9, and we always set that equal to 0. This you can easily solve by simply just factorizing right here, m plus 3 in brackets squared, and then we can easily find that m is equal to negative 3. Now what do we do with this thing? Well, there are a few different combinations of solutions you could get, and here's a nice little sort of cheat sheet which you do need to learn. So this is what we could get from the auxiliary equation, and this will be the complementary function, and the complementary function is what will be the first part of our general solution. So if we had 2 distinct roots where we have m equals, for example, 3 and 5, we would have it in this format here. If we had 2 equal roots a, which we do have here because we have, it's just m equal to minus 3, we would have it in this format here. An imaginary root, we'd have it in this format, and 2 complex roots, we'd have it in this format. Note that the imaginary roots one is similar to the complex roots one. It's just that the p here would just be a 0, so it's e to the power of 0, hence it's just 1 times all of this. But here you see how every single one of these complementary functions has a big A and a big B, capital. This essentially is how we get a general solution. We should always include these, and the first major tip I would give you is that your complementary function should always have A and B, because later on if you have to find a particular solution, which we do have to in this example, if you excluded the A and B here, you would actually realize that you can't find the particular solution. So first tip, always make sure when you form your complementary function, you should always have big A and big B, and you should just choose the right format, which you should learn. So here in this format, because we have 2 equal roots alpha, we have big A plus bx, but here obviously we're going to have t because we have an equation of x in terms of t, and then we're going to have it equal, close bracket, e to the power of minus 3t. So sort of mentioned this tip earlier, but just make sure to label everything really clearly. So I'm going to say this complementary function, I'm going to call it x1. Why am I calling it x1 instead of just x? Because our general solution will be x equals. So our complementary function is just the first part of that. So like we saw earlier, a plus b and then t, because here it's with respect to t, e to the power of minus 3t. If it was a homogeneous differential equation, this would be our general solution. But because it's non-homogeneous, i.e. it's not equal to 0, now we have to deal with the second part. Now how do we deal with the second part? We have to form something called the particular integral. Now the particular integral is probably the most tricky part of this, because we essentially have to make a guess for what we believe x could be. We're then going to differentiate it twice and plug it into this equation. There are a few sort of tricks you can use, and the trick here I would use is that if you have cosine or sine, your particular integral should always be lambda sine of whatever's here, which is 3t because it was cos 3t, plus mu cosine 3t. The lambda and mu are unknown, and we're going to solve for them. Then later on, we're going to rewrite the new particular integral with the new lambda and the new mu. So we're going to have, because we called this x2, we're going to have to differentiate this twice. So I would say dx by dt equals, and then we're going to differentiate this. So obviously sine differentiates to 3 lambda cosine 3t. Don't forget your rules of differentiation here, and then cosine differentiates to minus sine, but we have cosine 3t, so it's minus 3 mu sine 3t. Now we're going to have to differentiate this one more time. D squared x by dt squared is equal to, and then obviously differentiating just the t, we have minus 9 lambda sine 3t. And then the sine differentiates to cosine minus 9 mu cosine 3t. So now we have to sub these in, and then we're going to have a left hand side, and then we're going to have it equal to the cosine 3t, and then we're going to solve for lambda and mu. So because it had d squared x by dt squared, we're going to write that first here as minus 9 lambda sine 3t minus 9 mu cosine 3t. Watch out if there's any number in front or there's any negative sign, but here it's just a plus 6, so we're just going to have to watch out for the plus 6 when we sub in dx by dt, which tells us from above 3 lambda cosine 3t minus 3 mu sine 3t. Then don't forget the final part, which is the plus 9x. So the plus 9, and then the x. We're looking at the particular integral here, so we're just going to leave this bit out for now. So we're going to have the 9, open brackets 3. Sorry. We're going to have just the lambda sine 3t plus mu cos 3t, and that is going to be all equal to cosine 3t. We can simplify everything on the left hand side of the equation, so we're just going to group the lambda signs, and here we have a mu sign, but here we have a lambda sign. Minus 9 plus 9 cancels out nicely. We're going to have a 9 mu, and we're going to have a minus 9 mu, so that's also going to cancel out very nicely. We're going to get a lambda with cosine and a sine with cosine. So also just watch out, because this step sometimes you could deal with large brackets, so don't be afraid to write extra steps to ensure that you get every single part right. So 18 lambda cosine 3t minus 18 mu sine 3t is equal to cosine of 3t. So here we can just compare left and right. So here we have lambda is equal to 1 over 18, mu is equal to 0. So does that mean our particular integral was wrong at the start? No. Essentially, we just accounted for the fact that there may be a cosine and a sine by having the lambda sine plus mu cosine. There is absolutely no issue if the mu ends up as 0, which it has in this example. It'll just mean our particular integral is a bit more simple than we first thought. So yeah, just a tip that anytime it has a cosine or a sine, always just do this as your particular integral, unless if it features in the complementary function. So if there was a sine 3t plus cosine 3t, you'd actually need to write lambda t and mu t, but we'll look at that in a later video as a more complicated example. So again, just be very clear what we're labeling. So now we're doing the particular integral again, but now with our new values. So we have 1 over 18, and then because it had sine 3t, it's going to be sine 3t, and then obviously the mu is going to be 0. So this is our particular integral. Now we have all the parts now, so it asks for a general solution. So the general solution is always equal to the complementary function plus the particular integral, right? So you don't need to write this step, I'm just writing it out to show you exactly what we're doing. So now we can write x equals the complementary function above, which was open brackets a plus bt e to the minus 3t plus our particular integral, which is 1 over 18 sine 3t. And you can see there, that is our 8 marks. And when you actually sort of break it down into steps, it's not actually that much for 8 marks. And although this is one of the more simple questions, you might get more complicated numbers, more annoying auxiliary equations, which means you'd have like this annoying, for example, complementary function here. This one's a simple one, but like I said before, if you just follow this very clear method, you label everything like the auxiliary equation and the complementary function and the particular integral, then the general solution, you'll find that these questions, you can do them very quickly and you can get all the marks. So that is part A. Now part B asks, find the particular solution of this differential equation for which at t equals 0, x equals a half, and dx by dt equals 0. So we're going to have to use our general solution to now find a particular solution. Now what does that mean? Well, our general solution at the start just had x in terms of t, right? But we also have capital A and capital B, which we aren't aware of. So now it's given us some conditions, and now we're essentially going to have to find these values of A and B. So we're just going to get an equation of x in terms of t. And now to solve that, obviously it needs to give us quite a lot of information. So here it's given us the first bit of information, which is that when t equals 0, x equals half. I'm just going to write 0.5. And when we plug that all in, we're going to have 0.5 is equal to, and then you see how the t equals 0 means that this sign is going to be just 0 because sine of 0 is 0. This e of minus 0 is going to be just 1, so it's going to be a plus bt, which is just going to be a plus 0, so a. Very nice. That'll usually just be a mark. The second bit is a bit more complicated, but like I said before, the method is very straightforward. So the second bit of conditions, it told us while t is 0, dx by dt is 0. So when t equals 0, dx by dt equals 0. So now what do we need to do? Well, we have an x here, so now we need to differentiate this equation. And then what we're going to do is sub in the t0, dx by dt equals 0. We could even sub in the a, but I'll show you that you don't need to because you can just get two simultaneous equations. But now we need to differentiate the equation above. Don't forget your product rule. Don't forget your chain rules. Watch out very carefully here. So the first bit, we're going to differentiate the first part in the bracket, so it's just going to end up being b times e to the minus 3t, and then it would be plus, but now we left this bracket here untouched, and we're going to differentiate the e to the minus 3t, so it's going to be minus 3 e to the minus 3t. So I'm just going to have minus 3 e to the minus 3t a plus bt. Obviously the sine of 3t here differentiates to 3 cosine 3t, so the 3 times 1 over 18 is going to be 1 over 6, so plus 1 over 6 cosine 3t. So with the conditions above, we can just plug in everything now. So when t equals 0, 0 equals, it's just going to be 1 here because it's going to be e to the 0, so 1, so b times 1 is b, minus, and then we're going to have 1 here because it's going to be e, again, e to the power of 0, which is just 1, so minus 3, and then the bt is just going to be 0, so it's just going to be minus 3a, and then the cosine of 3t is just going to be 1, so plus a 6. So we have one simultaneous equation and the second simultaneous equation. Obviously this one's quite easy because we can just plug in the a directly here and we get a value of b, but sometimes it might be like a plus b whatever, and then you would actually need to do two simultaneous equations. But here we can quite nicely just rearrange this. So I'll just write 2, I'm dealing with equation 2, which is that b is equal to 3a minus 1 over 6. So the a is obviously a half, so 3 over 2 minus 1 over 6. 3 over 2, that would be 9 over 6 minus 1 over 6, which will be 8 over 6, which will simplify to b equals 4 over 3. Is that it? No, because now we need to write the particular solution. It means very simply, we're just going to write PS for particular solution. I'm going to sub in our values of a and b. So you don't need to times everything out, you don't need to have it as a very nice format, you can literally just plug a and b as they are. So a half plus 4 over 3 t e to the minus 3t, and then the last bit is going to be plus 1 over 18 sine 3t as your particular solution. If you wanted to times it out, you could. I personally wouldn't waste time. I would just leave it at that because you get your 5 marks from essentially just proving that you know how to form your general solution, how to differentiate that, and with the conditions you've given in the question, you can plug in those numbers. So you can see how for 13 marks, it's not actually that much working out. It's just how you can see how if you made a mistake early on here, for example, with your complementary function, if you didn't memorize this and you sort of made a mistake early on, then you might find that your general solution is wrong, so then your particular solution is wrong. And it'd be a shame to lose out on these marks because it is quite simple when you learn the method. Although this was a more simple question, the principle is the same. So this is how to solve a second order non-homogeneous differential equation. I hope you benefited from this lesson, and we'll look at a more advanced question later on. Thank you very much.